Welcome to Trikana Skill, your lifetime career partner. Trikana is a pioneer and trailblazer in the field of civil engineering and construction training, seeking to bridge the gap between engineering studies and the construction industry. Soil California Bearing Ratio Test or CBR Test. IS 2720 Part 16 1979. California Bearing Ratio. It is the ratio of force per unit area required to penetrate a soil mass with standard circular piston at the rate of 1.25 mm per minute to that required for the corresponding penetration of a standard materials. CBR equals test load divided by standard load into 100. The following table gives the standard loads adopted for different penetrations for the standard material with a CBR value of 100%. The test may be performed on undisturbed specimens and on remolded specimens, which may be compacted either statically or dynamically. Objective: to determine the California bearing ratio by conducting a load penetration test in the laboratory. Need and scope. The California bearing ratio test is penetration test meant for the evaluation of subgrade strength of roads and pavements. The results obtained by these tests are used with the empirical curves to determine the thickness of pavement and its component layers. This is the most widely used method for the design of flexible pavement. Equipments and tools. Cylindrical mold with inside dia 150 mm and height 175 mm, provided with a detachable extension collar 50 mm height and a detachable perforated base plate 10 mm thick. Spacer disc 148 mm in dia and 47.7 mm in height along with handle. Surcharge weight of 2.5 kg and having hole 53 mm of diameter. Slotted weight of 2.5 kg and having hole 53 mm of diameter. Penetration plunger of diameter 50 mm and height 100 mm. Loading machine of capacity of 5,000 kg and capable of travang vertically at a rate of 1.25 mm per minute. Miscellaneous apparatus such as a compaction rammer, proving ring, dial gauges, mixing tools, filter papers, weighing balance, measuring cylinder, preparation of test specimen, undisturbed specimen. Attach the cutting edge to the mold and push it gently into the ground. Remove the soil from the outside of the mold which is pushed in. When the mold is full of soil, remove it from weighing the soil with the mold or by any field method near the spot. Determine the density. Remolded specimen. Prepare the remolded specimen at Proctor's maximum dry density or any other density at which CBR is required. Maintain the specimen at optimum moisture content or the field moisture as required. The material used should pass 20 mm IS sieve, but it should be retained on 4.75 mm IS sieve. Prepare the specimen either by dynamic compaction or by static compaction. Dynamic compaction. Take about 4.5 to 5.5 kg of soil and mix thoroughly with the required water. Fix the extension collar and the base plate to the mold. Insert the spacer disc over the base. Place the filter paper on the top of the spacer disc. Compact the mixed soil in the mold using either light compaction or heavy compaction. For light compaction, compact the soil in 3 equal layers, each layer being given 55 blows by the 2.6 kg rammer. For heavy compaction, compact the soil in 5 layers, 56 blows to each layer by the 4.89 kg rammer. Remove the collar and trim off soil. Turn the mold upside down and remove the base plate and the displacer disc. Weigh the mold with compacted soil and determine the bulk density and dry density. Put filter paper on the top of the compacted soil, collar side, and clamp the perforated base plate onto it. Static compaction. Calculate the weight of the wet soil at the required water content to give the desired density when occupying the standard specimen volume in the mold from the expression W equals desired dry density into 1 plus W into V. where W equals weight of the wet soil. W equals desired water content. V equals volume of the specimen in the mold equals 2,250 centimeters cubed, as per the mold available in laboratory. Take the weight W, calculated as above, of the mixed soil and place it in the mold. Place a filter paper and the displacer disc on the top of soil. Keep the mold assembly in static loading frame and compact by pressing the displacer disc till the level of disc reaches the top of the mold. Keep the load for some time and then release the load. Remove the displacer disc. The test may be conducted for both soaked as well as unsoaked conditions. If the sample is to be soaked, in both cases of compaction, put a filter paper on the top of the soil and place the adjustable stem and perforated plate on the top of filter paper. Put annular weights to produce a surcharge equal to weight of base material and pavement expected in actual construction. Each 2.5 kg weight is equivalent to 7 cm construction. A minimum of 2 weights should be put. Immerse the mold assembly and weights in a tank of water and soak it for 96 hours. Remove the mold from tank. Note the consolidation of the specimen. Procedure for penetration test. Place the mold assembly with the surcharge weights on the penetration test machine. Seat the penetration piston at the center of the specimen with the smallest possible load, but in no case in excess of 4 kg so that full contact of the piston on the sample is established. Set the stress and strain dial gauge to read 0. Apply the load on the piston so that the penetration rate is about 1.25 mm per minute. Record the load readings at penetrations of 0.5, 1, 1.5, 2, 2.5, 3, 4, 5.0, 7.5, 10, and 12.5 mm. Note the maximum load and corresponding penetration if it occurs for a penetration less than 12.5 mm. Detach the mold from the loading equipment. Take about 20 to 50 grams of soil from the top 3 cm layer and determine the moisture content. Observation and recording. For dynamic compaction. Dynamic compaction is performed and values are tabulated as. For penetration test. Penetration test is also performed and values are noted. Calibration factor of the proving ring for 1 division equals 1.176 kilograms. Surcharge weight used, kg, for 2.6 kg per 6 centimeters construction. Water content after penetration test %. Least count of penetration dial is 1 division. Equals 0.01 mm. After finishing the procedure, the load corresponding to penetration values are calculated by using proving ring readings. Interpretation and recording. CBR equals test load divided by standard load into 100. The CBR values are usually calculated for penetration of 2.5 mm and 5 mm. Generally the CBR value at 2.5 mm will be greater than at 5 mm, and in such a case or the former shall be taken as CBR for design purpose. If CBR for 5 minutes m exceeds that for 2.5 mm, the test should be repeated. If identical results follow, the CBR corresponding to 5 mm penetration should be taken for design.
Thank you for your time. If you have any queries, do not hesitate to contact us.